Hi, so my name is Aseem Jain, and in this lecture we are going to learn about NodeJs streams. So just to give a recap of last lecture, we have learnt about the event binding in Node.js. So event binding is a very important concept because you can bind any function to any event, and JavaScript Node.js is a event-driven framework or technology which works on the event cycle or event loop. So at after particular microseconds, the event loop happens and events are getting emitted and listened based on that asynchronous behavior or parallelism or multiple concepts are achieved. So we learnt about how events are getting created and how your events are getting listened, event removal, lot of stuff in the last video. So please refer to that video for deeper understanding of the concepts. Right now we are going to learn about streams. So stream are objects that let you read data from a source or write data to a destination in continuous fashion. In data in Node.js, there are four type of streams. So continuous fashion, I'll give you a real life example is if you order five things from Amazon. So there are two ways. First is you can receive the continuous delivery. Let's say your first order is available and they'll ship it. They'll not wait for the other orders to get combined to ship, which is bit expensive. So as soon as your product is available at their end, they will send it to the destination and you can receive them continuously one after another. However, in the first like another approach is at the Amazon and they will wait for all the orders, they'll put it in a big box and they'll send you a big box. So that is a non-continuous. So when they send piece by piece items, that is called they are sending it chunks. They will send it in chunks, otherwise as a whole. So these are streams in any programming language: input, output, and process. That's what a programming language does. So input is a stream, output is a stream, and then you do process. So how many streams are there? So first is your readable stream, which is used to read operation. Then writable stream. Then there is something called as duplex stream, which can be used for both read and write. And then transform, which is type of duplex stream where the output is computed based on the input. Now each type of stream is an event emitter instance and throws several events at different instance of time. For example, some of the commonly used events are, so there is a event which is called as data. The event is fired when there is data available to read. End means the event is fired when there is no more data to read. So you are reading from something. There is a Mahabharat, very big file which is having 1,000 pages. So two approaches: you read everything, you put it in buffer, and then you transport or something. Second is from the source you will read page by page, and you can send chunk by chunk. Whenever some data is available, data event is fired, your listener will listen and will consume that page. After, if it gets another another event loop, it gets another data, it will read. If it gets and event, basically and event gets triggered, it will understand automatically that there is no more data which is going to get sent in another event loop cycle. So that's how it happened. Unfortunately, if there is some error which might have happened in reading the chunk of the file, network issue, then the event with the name error is triggered. So this event is fired when there is any error receiving or writing data. Finish, this event is fired when all data has been flushed to the underlying system. So underlying system means you're let's say reading something and you're writing it either on the log file, or you're writing it into the response, or you can write it to another stream as well. So whenever everything is done, rather you can imagine and is done and you are not expecting any more data or nothing, then finish can even remove your event listener. At the finish, you can just destroy the event. We under learned the how to remove the listeners in the last lecture. Just refer that. and we'll also look on some hands-on code now. So reading from a stream, so we can create an input file which will have some data, and then we can create a file. So how it goes is FS has create read stream. Once we do this, this will read it from this file and it will provide you a stream. Now in stream you can set UTF-8, or you can set say ASCII, and there are different encodings which are available. Node being friendly to UTF-8. So there is ASCII which would support some 250 characters max, which would include your numbers, special symbols, and alphabets in lower and upper cases, which is mainly used for English language. It's good, but it doesn't have other data like for international other than English. So that is faster, though ASCII is faster and it consumes less space, but it's typically meant for English only version. But if you might have to read Chinese, you might have to read Hindi, Bengali, Tamil, Telugu, whatever, they have some different representation of each character, and word is a combination of character. So all those symbols, character, everything, when you need to read that or work on those stuff, so you have to specify UTF-8, which is a standard. And once you set this encoding, whatever data which is traveling in the stream, program will understand, okay, what kind of character mapping is it. If it's a 1001100, there is some binary pattern, it will understand for, of course, and will print it. Just some information on UTF. Now next line, handle stream events, data, and an error. So whenever read stream has a event which is called as data, it will by default pass a chunk inside the function, and then you can have your local variable inside it which is called as data, and you plus is equal to means chunk is equal to data plus, it's just your appending it's the C operator, wherever you are appending each chunk inside the data. Data is equal to data plus chunk, or data is equal to data dot append chunk. It's the short version of that. Then you're trying to read stream on. So this is your read stream instance, inside which whenever there is AND event happen, you can write it to the log. Whenever error happens, you can print the error stack, and whenever it gets finished, you can do probably logging or removal of those events or something like that. So let's try to real quick run this program in our stream file. So for interest of time, I have already created a file over here. So we can use the stream. We can make a folder which is called as stream. Inside stream, we can make a file called as main.js, and we will have all the data. Now once we run this, the listener which is having the error, that should be invoked. So basically what has happened, program ended, and it is giving the error that there is no file which is called as input. So this listener got invoked. So let's try to put a input file in the desired directory, and request this program to run a happy patch. So we have the input file now available. So let's try real quick and run this main.js now. So this time it has started logging, and since it's asynchronous, program ended has invoked as soon as it went through the function, and after some time, as soon as the chunk was available, it started reading chunk by chunk, and then it started collecting it inside the data over here. So that's what was happening whenever the data was there, and at the end when everything got uh, mm, appended in this, you got to log the entire file contents basically. which we just repeated some random value inside it. That's how it happened, that each event has been invoked or mapped or binded on top of the stream. So let's go back here. Now writing to a stream. So this is we learned the first time of stream, which is called as reading. Now writing would be something similar. You will have a handler function. You will create the instance of write, and then you will have the handler function. Whenever so you are writing, right? So you are writing to a output text file, and then you are writing in UTF-8 format, and mark the end of the file whenever it's done, and it when it's finished you will give a log message that it has been completed, and then the error log. So as soon as you write this, program ended, log completed, and you will happen to see the output file. So let's try to do this. So we can say here output stream. This one is your output stream. Let me run this. So here please observe there is no output.txt file. As soon as you run this, okay, so we have not imported the first required module. So let's try to do that. That's why it came up. So now it has been written. So observe that output.txt has just been shown up. So program ended, your write, as soon as your write got completed, whatever write you was doing, uh, the event has been thrown over here, and the data which you have passed to the write stream is over here. Simply easy learning. So let's validate that in the output.text. Yes. So whatever data you are trying to pass to the stream, one by one, chunk by chunk, it would go there and it would start writing it over here. Now there is something which is called as piping the streams. Piping the stream means you can read from one stream and you can write it to another stream. Piping is a mechanism where we provide the output of one stream as the input to another. It is normally used to get data from one stream and to pass the output of that stream to another stream. There is no limit on piping operation. Now we will show a piping example for reading from one file and writing to another file. So we need the import of this. We will read it from this, write it from here, and just will say read stream.pipe, and it takes the argument as write stream. So we will real quick do this stuff in this same file, and let's see what happens. So let's try to read about output. So whatever data was there previously in output, that has been giving trouble. So that has been returned to the output stream. So that is how the piping works. Now we will try to understand about the chaining, how chaining works. So in this example, we are trying to, let's try to save this, and let's try to make another file which is called as chaining. Now inside this chaining, we will have this data over here, which would do nothing, but it would read from the create read stream. From the input file it would start reading, and then it would start compressing, and you are piping. So there are three streams which are working in parallel, but as soon as it is done, you will find the input got compressed. So that is how the pipe happens and file compression happens. So this concludes the lecture for streams in Node.js. Thanks for watching.